How are you, everybody who is watching this video? My name is Olenjolaim Moko TAYAI Losingo. Simply just call me Sir Olenjolaim. I'm very happy to have you today, whether a national or international viewer. You're warmly welcome. You are in a very comfortable and conducive environment for you to learn the beauty of engineering mathematics, the beauty of undergraduate education in any institutions or worldwide, especially by using the curriculums of Tanzania. I'm from Tanzania. This is our national flag. I'm a Tanzanian. Okay, I'm a citizen of Tanzania. I'm also a citizen of the kingdoms of heaven of another distant country. I'm very happy to have you, and I would like to welcome all the foreigners to our beautiful country to invest in, to live temporary, to visit it, to do touristing in our national parks, to do touristing in the longest mountains, that's the Kilimanjaro mountains. So we welcome all the international viewers to enjoy the beauty of natural resources and how did God bless it. But another thing that we enjoy are the foreigner in Tanzania, God's live in Tanzania. So the owner of this country, of this beautiful country that is Tanzania, is God himself. So you will enjoy the presence of God once you are in any regions of Tanzania, because God lives and reigns forever and ever. So I would like to take this opportunity to welcome you into one of our online institutions that's called Online Undergraduate Polytechnic Institute of Tanzania, in square bracket Olenjolaim. Simultaneously, because I'm going to teach you engineering mathematics, I'm going to welcome you into one of our YouTube channels that's called Online Undergrad. These are the abbreviations of undergraduate, so I just skipped these letters when I was just designing the name of the channel. Then Poly Institute, these are the combinations and abbreviations of the two words Polytechnic Institute of Tanzania, in square bracket OLENJOLAI. So we have so many departments, but one of the departments is called the Higher Engineering and Scientific Mathematics. We have also another department which is very interesting, that's called Kingdom of Heaven. And before even I go further, I would like just to remind you the vision that we have in Online Undergraduate Polytechnic Institute of Tanzania. This is the vision that we have. We have an assignment from God himself, who have created us, because I come from the kingdoms of heaven myself, and I have a special assignment here. I have to accomplish it, and I go back to live forever and ever with my Father. So this is an assignment that I have, just to train, to teach, to incubate, to mentor, to lead, and even to encourage some group of students who want to extract the knowledge from their classroom instructions in engineering and science for undergraduate level, to combine with the knowledge from the Word of God written in the Holy Bible, in order to solve real life problems. So our visions has four parts. The first part, to extract the knowledge from the formal or informal education, classroom education. And the second part is to extract the knowledge from the Word of God, because the Word of God there comprises so many things. But one thing which is actual, that is wealth, because the Word of God is wealth, is the wisdom and knowledge. So we are going to learn how to extract it. And then we combine these two knowledge in order to solve real life problems in your community, to solve real life problems in your family, to solve real life problems in your own house, in your own family, in your own compounds, in your parents' family, because they are still waiting. That's why you went to school, in order to solve real life problems. Well, I know you will be employed, but don't end in the employment. Employment, just you are solving a particular problem, but just a small portions. What God has hidden in you is more than what the employment you are going to get will be utilized. So it means you are full enough, and even the employments will just consume small portions of what God has created in you. So don't be limited in employments. You are going to sell some number of hours. So the remaining time, then make sure that you develop your own shifty, and then you make your own product in your own garage. I know that many of you expect to be practical engineers, and this is the right place right now. You are actually the place where I will be changing your mindset from theoretical engineer, or from just a poor skilled engineer, into the efficient, or into the competent theoretical and practical engineer. So this is the right place, and you have to stay tuned, because it's a process. It's not just a work of a single day. So our main objective is to see our continuing students solving real life problems, and even our graduate students solving real life problems. So that's the vision we have. That's our main goal. our main goal to see you are solving problems. It might be taking several months, it might be taking so many years, but that is our destiny. So I believe that one day, after maybe 5 years, we achieve what I'm telling you right now, because it's the long-time vision that we have in our mind. We have a mission also in this online institution that we'll be sharing with you when we'll be continuing with other lectures. So as I say that we are in Departments of Higher Engineering and Scientific Department, Mathematics, and we are teaching by using the curriculums of Tanzania institutions or universities. In Tanzania, we have two institutions, two authorized, just two authorities that supervising and they oversee everything about undergraduate education. That is TCU, Tanzania Commission for Universities, and also NACTE, National Council for the Technical Education. So these two TCU focus on the knowledge-based and NACTE focus on the competence-based. So with this module, we are going to teach with perspective of TCU mindset, which is knowledge-based, and the actual that we are teaching engineers and scientists, and the names of the module or the course, the name of the course or modules is called Matrices and Basic Calculus. At University of Dar es Salaam, this course is called MT161. So that's the module code. We call it the course code. So we are using the curriculums of University of Dar es Salaam. However, that this is the actual that all the institutions, all the engineering institutions, engineering colleges and engineering universities in Tanzania, they are using or they are studying this course. Either part of this course or the entire course. Whether it is University of Dodoma, they are studying this course. Whether it's African University of Tanzania, also they are studying this course. Because there's another, there are so many. For example, State University of Zanzibar, they are studying also this course. So this is the common, it's a cross-cutting course. So regardless whether you are national, international students, another point which I want to make before I go into today's session is this one. Remember that mathematics is universal. We in Tanzania, we have never discovered anything, and we have never added any contribution, anything. Yes, I can say that we have never added, we have never added great things in undergraduate engineering mathematics. So whether you're international students, maybe from any African country, or from Asia, or from Australia, or from Europe, or from North America, or from South America, stay tuned. You're gonna get all the contents that is required for your undergraduate education. So don't be disappointed for me mentioning on the curriculums of University of Dar es Salaam, or we call it UDSM. Don't be disappointed about that. The issue is focus on the content. Okay? So let us go to today's session, or today's lecture. So the lecture of the day, first of all, we are in chapter 1, that's called Vector and Algebra. And hence the vector of today, this is lecture 4, Operations of Vectors, and the year of study at the University of Dar es Salaam and all other institutions or colleges or universities. They learn this module in this course in first semester of the first year. So if you are pre-undergraduate student, this is the right course for you to start at home even before you join any university or engineering, or scientific university or institutions where you are going to learn about engineering mathematics. So you should not wait until you are there. You can start learning this stuff while you are at home. That's the good news for the pre-undergraduate students. So let us begin with quick review, because I always link my lecture. Quick review of what? So if we are learning about lecture 4, it means we have already taught about lecture 7, because that's the sequential order. It's ascending order. My lectures are ascending order, and I always begin from the fundamental concept. I go to I teach you intermediate concept, and I teach you advanced concepts, and I teach you advanced concept, and then possibly we might end the course there. Okay, so I'll be using different teaching aids. Remember that I want to say this in advance. I used to say this, and I want to say this, and I'll repeat on saying this one. OLENJOLAI does not know everything concerning about matrices and basic calculus. I know small portions, but I'm ready to teach other people what I know. So I know small portions of mathematics, of engineering and scientific mathematics, but I'm ready to teach other people like you what I know. I'm always learning. I'm always a student of engineering, of higher engineering and scientific mathematics for the rest of my life. So in lecture 3, it has been titled as terminologies. I taught you about terminologies, okay, terminologies of vector, So terminologies of vector. So I have taught you so many terminologies. one among those many I taught you about position vector. Then I taught you another terminology that we call opposite vector. Then I taught you about we call them equal vector. Opposite vector. Yes, we have something called equal vector, or yes, equal vector. If I'm not mistaken, let me check. We call them equal vector. I think that it is clicking in my mind that is equal vector. So we call them equal vector. I taught you another terminology that we call displacement vector. Displacement vector. I taught you another terminology that we call displacement vector, very important. I taught you about another terminology we call unity vector. Taught another terminology that we call magnitude of the vector, or we call it norm of the vector, and so and etc. And then I ended in example 4, which I left it as a homework for you. So in this lecture for operations of vectors, before I teach about operations of vectors, I would like first of all to teach you the 9th terminology. And this 9th terminology, I'm not sure if I told you, but I had in my heart that I have to insist you. It's about direction of a vector. So direction of a vector, or in some of the books we call it. How are you, everybody who is watching this video? My name is Olenjolaim Moko TAYAI Losingo. Simply just call me Sir Olenjolaim. I'm very happy to have you today, whether a national or international viewer. You're warmly welcome. You are in a very comfortable and conducive environment for you to learn the beauty of engineering mathematics, the beauty of undergraduate education in any institutions or worldwide, especially by using the curriculums of Tanzania. I'm from Tanzania. This is our national flag. I'm a Tanzanian. Okay, I'm a citizen of Tanzania. I'm also a citizen of the kingdoms of heaven of another distant country. And I'm very happy to have you, and I would like to welcome all the foreigners to our beautiful country, to invest in, to live temporary, to visit it, to do touristing in our national parks, to do touristing in the longest mountains, that's the Kilimanjaro mountains. So we welcome all the international viewers to enjoy the beauty of natural resources and how did God bless it. But another thing that we'll enjoy as the foreigner in Tanzania, God's live in Tanzania. So the owner of this country, of this beautiful country that is Tanzania, is God himself. So you will enjoy the presence of God once you are in any regions of Tanzania, because God lives and reigns forever and ever. So I would like to take this opportunity to welcome you into one of our online institutions that's called Online Undergraduate Polytechnic Institute of Tanzania, in square bracket Olenjolaim. Simultaneously, because I'm going to teach you engineering mathematics, I'm going to welcome you into one of our YouTube channels that's called Online Undergrad. These are the abbreviations of undergraduate, so I just skipped these later when I was just designing the name of the channel. Then Poly Institute, these are the combinations and abbreviations of the two words Polytechnic Institute of Tanzania, in square bracket OLENJOLAI. So we have so many departments, but one of the departments is called Higher Engineering and Scientific Mathematics. We have also another department which is very interesting, that's called Kingdom of Heaven. And before even I go further, I would like just to remind you the vision that we have in Online Undergraduate Polytechnic Institute of Tanzania. This is the vision that we have. We have an assignment from God himself, who have created us, because we are come from the kingdoms of heaven myself, and I have a special assignment here. I have to accomplish it, and I go back to live forever and ever with my Father. So this is an assignment that I have, just to train, to teach, to incubate, to mentor, to lead, and even to encourage some group of students who want to extract the knowledge from their classroom instructions in engineering and science for undergraduate level, to combine with the knowledge from the Word of God written in the Holy Bible, in order to solve real life problems. So our visions has 4 parts. The first part, to extract the knowledge from the formal or informal education, classroom education. And the second part is to extract the knowledge from the Word of God, because the Word of God there comprises so many things. But one thing which is actual, that is wealth, because the Word of God is wealth, is the wisdom and knowledge. So we are going to learn how to extract it. And hence we combine these two knowledge in order to solve real life problems in your community, to solve real life problems in your family, to solve real life problems in your own house, in your own family, in your own compounds, in your parents' family, because they are still waiting. That's why you went to school, in order to solve real life problems. Well, I know you will be employed, but don't end in the employment. Employment just you are solving a particular problem, but just a small portions. What God has hidden in you is more than what the employment you are going to get will be utilized. So it means you are full enough, and even the employments will just consume small portions of what God has created in you. So don't be limited in employments. You are going to sell some number of hours. So the remaining time, then make sure that you develop your own shifting, and then you make your own product in your own garage. I know that many of you expect to be practical engineers, and this is the right place right now. You are actually the place where I will be changing your mindset from theoretical engineer, or from just a poor skilled engineer, into the efficient, or into the competent theoretical and practical engineer. So this is the right place, and you have to stay tuned, because it's a process. It's not just a work of a single day. So our main objective is to see our continuing students solving real life problems, and even our graduate students solving real life problems. So that's the vision we have. That's our main goal. Our main goal to see you are solving problems. It might be taking several months, it might be taking so many years, but that is our destiny. So I believe that one day, after maybe 5 years, we achieve what I'm telling you right now, because it's the long time vision that we have in our mind. We have a mission also in this online institution that we'll be sharing with you when we'll be continuing with other lectures. So as I say, that we are in departments of higher engineering and scientific department, mathematics, and we are teaching by using the curriculums of Tanzania institutions or universities. And in Tanzania, we have two institutions, two authorized, just two authorities that supervising and they oversee everything about undergraduate education. That is TCU, Tanzania Commission for Universities, and also NACTE, National Council for the Technical Education. So these two TCU focus on the knowledge-based, and NACTE focus on the competence-based. So with this module, we are going to teach with perspective of TCU mindset, which is knowledge-based, and the actual that we are teaching engineers and scientists, and the names of the module or the course, the name of the course or modules is called Matrices and Basic Calculus. At University of Dar es Salaam, this course is called MT161. So that's the module code. We call it the course code. So we are using the curriculums of University of Dar es Salaam. However, that this is the actual that all the institutions, all the engineering institutions, engineering colleges and engineering universities in Tanzania, they are using or they are studying this course. Either part of this course or the entire course. Whether it is University of Dodoma, they are studying this course. Whether it's African University of Tanzania, also they are studying this course. Because there's another, there are so many. For example, State University of Zanzibar, they are studying also this course. So this is the common, it's a cross-cutting course. So regardless whether you are national, international students, another point which I want to make before I go into today's session is this one. Remember that mathematics is universal. We in Tanzania, we have never discovered anything, and we have never added any contribution, anything. Yes, I can say that we have never added, we have never added great things in undergraduate engineering mathematics. So whether you're international students, maybe from any African country, or from Asia, or from Australia, or from Europe, or from North America, or from South America, stay tuned. You're gonna get all the contents that is required for your undergraduate education. So don't be disappointed for me mentioning on the curriculums of University of Dar es Salaam, or we call it UDSM. Don't be disappointed about that. The issue is focus on the content. Okay? So let us go to today's session, or today's lecture. So the lecture of the day, first of all, we are in chapter 1, that's called Vector and Algebra. And hence the vector of today, this is lecture 4, Operations of Vectors, and the year of study at the University of Dar es Salaam and all other institutions or colleges or universities they learn this module in this course in first semester of the first year. So if you are pre-undergraduate student, this is the right course for you to start at home even before you join any university or engineering, or scientific university or institutions where you are going to learn about engineering mathematics. So you should not wait until you are there. You can start learning this stuff while you are at home. That's the good news for the pre-undergraduate students. So let us begin with quick review, because I always link my lecture. Quick review of what? So if we are learning about lecture 4, it means we have already taught about lecture 7, because that's the sequential order. It's ascending order. My lectures are ascending order, and I always begin from the fundamental concept. I go to I teach you intermediate concept, and I teach you advanced concepts, and I teach you advanced concept, and then possibly we might end the course there. Okay, so I'll be using different teaching aids. Remember that I want to say this in advance. I used to say this, and I want to say this, and I'll repeat on saying this one. OLENJOLAI does not know everything concerning about matrices and basic calculus. I know small portions, but I'm ready to teach other people what I know. So I know small portions of mathematics, of engineering and scientific mathematics, but I'm ready to teach other people like you what I know. I'm always learning. I'm always a student of engineering, of higher engineering and scientific mathematics for the rest of my life. So in lecture 3, it has been titled as terminologies. I taught you about terminologies, okay, terminologies of vector, So terminologies of vector. So I have taught you so many terminologies. One among those many, I taught you about position vector. Then I taught you another terminology that we call opposite vector. Then I taught you about we call them eco-vector. Opposite vector. Yes, we have something called eco-vector, or yes, eco-vector. If I'm not mistaken, let me check. We call them eco-vector. I think that it is clicking in my mind that is eco-vector. So we call them eco-vector. I taught you another terminology that we call displacement vector. Displacement vector. I taught you another terminology that we call displacement vector, very important. I taught you about another terminology we call unity vector. Taught another terminology that we call magnitude of the vector, or we call it norm of the vector, and so and etc. And then I ended in example 4, which I left it as a homework for you. So in this lecture for operations of vectors, before I teach about operations of vectors, I would like first of all to teach you the 9th terminology. And this 9th terminology, I'm not sure if I told you, but I had in my heart that I have to insist you. It's about direction of a vector. So direction of a vector, or in some of the books we call it angle of a vector. Okay, angle of a vector. Okay, so this is number 9, and I will teach about it because our discussion today is about operations. We are going to discuss about additions of the vector, subtraction of the vector, algebraically and geometrically, and also scalar multiplications. We won't touch about dot product. Dot products will be at the next session after this one. It will be the lecture 5. Okay, with the lecture 5. So you have to stay focused, and I don't think that we are going to advance from what you knew or what you learned in your advanced educations, or in advanced mathematics, or in your ordinary diploma, basic engineering and scientific mathematics. So when you say about direction of a vector, what does it mean? So direction means the angle. Okay? So you say that a direction of a vector, simply this is the angle. So you say that is the angle formed between, so this is the angle formed between a vector line vector line and the horizontal axis, which in XY plane we call it the x-axis of XY plane, horizontal axis or x-axis of horizontal of XY plane. Okay, so how it is achieved? So let me show you. So suppose that, let me show you geometrically, and then I will teach you how you can now derive the formula of finding the direction of a vector. It's a very simple concept, I just remind you, because we are going to use it in some concept of vector algebra. Okay, so here we have, this is y-axis, and this is the x-axis. So this is 0, 0. All right? So y-axis, x-axis. So we say that suppose we have a positional vector. This positional vector is positional vector OA possibly. So positional vector OA. And this positional vector OA, it has two, because this is a two-dimensional. We are discussing for the two-dimensional, because for the three-dimensional, we can have something we call the directional cosine, which is not recommended in your syllabus to cover, but we can also teach you in case you are in demand of that concept. Let us know in the comment section, then we can teach you. Okay, so this is the vector A. Okay, that's the vector A, and hence to make a right angle triangle, and here it is angle between a line of vector A and the x-axis or horizontal axis. So this is, we know that it's a y component, and this is, it is x component. So suppose that this is OAB triangle. So it means that if you want to know the direction, which the angle, for this case, we have to apply the Pythagoras theorem. So if the first step with that one, we have to recall the Pythagoras theorem. So to recall Pythagoras theorem, we say that there's no even need to recall the Pythagoras theorem. Yes, okay, yeah, okay, just there's no need to recall the Pythagoras theorem. You just have to consider the right angle triangle. So we say that consider right angle triangle A or A, B, A. Or A, B, O. Okay. So if you consider it, we say that the tangent of angle theta, this is equal to what? Is equal to opposite side over adjacent. Okay? So the opposite, so now we say that the tangent of angle theta for that figure, so suppose that this is, we call it figure 421. The tangent theta, what the opposite of this right angle triangle, the opposite of this angle, of the angle theta is y. So it's equal to y over what the adjacent of this right angle triangle, the adjacent is x. So y over x. What's our intention? Our intention is to get theta. So we have to divide by tan, and then these expressions also we have to divide by tan. So then we say theta is equal to what? We have 1 over tan, and then here we have y component over x component. 1 over tan in mathematics, we call it, that is tan inverse of y over x, and this is equal to arc tan of what? Tan of y over x. So this is the formula to find angle or to find the direction of a vector. Okay, find the direction of a vector. So just to support that knowledge, let me give you an example, which will be example 5. An example, simply just to support that, for those who have forgotten, because everything is clear there. but because you have some trigonometric information, so let us maybe do an example of finding the directions of the particular vector. Okay, find the directions of negative 2i plus 2j. Okay, so this is example 5. So given Roman A, vector 2i plus z negative 2i, or yes, negative 2i plus 2j. And then Roman B, the B given us another vector which is 6i plus 4j. Okay, then we say that find the direction of each vector. Of each vector above. So solution. The first state, we just say that compare vector negative 2i plus 2j with what is standard vector, which is xi plus yj. So if you compare, we find that the value of x is negative 2 and the value of y, this is equal to positive 2. Okay? Then, so this is part B, this is quiz. You just try yourself, because I want to teach about operations of vectors. Okay? Then we say that second step we say that we call the formula. What formula? Call the formula of finding what? Of finding direction. Direction of what? Direction of a vector. Direction of a vector. What that formula? So direction of the vector we just define by finding an inverse of y component of vector over x component of vector. So directions of the given vector is theta is equal to an inverse of what? Y component is 2 and the x component is negative 2. So 2 over negative 2 is equal to negative 1. So theta is equal to tan inverse of negative 1. So then theta now, you may use just your scientific calculator. Again, I want to remind you that in online undergraduate Polytechnic Institute of Tanzania, in square bracket Olenjolaim, we have also online library where that we are providing materials and textbooks, soft copy, hard copy, and also questions and answers books, just to equip our undergraduate students so they can they can go far as well as they can, as well as they wish. So one of the material is original scientific calculator, and we recommend Casio function 991, that's before your screen right now. And this is the one of the original scientific calculator. So you have this scientific calculator, you can go to the descriptions and read the information, because you have different modes and different size and different products, or different yes, we got different products of Casio, because Casio is just the brand names. So you can order this scientific calculator in any regardless of which institutions you are studying right now. We can ship in all 31 regions, including Pemba and Unguja. So it's a time right now for you to make sure that you place the order, you just buy it. We are providing service, just our price is minimum compared to the price that you will find in the local shops, and sometimes they can sell a fake an original scientific calculator because we know them. So I met with them because I've been using the scientific calculator for more than 13 years right now. So I know the original and the fake one. So I will be trying to make sure that you get the right product and you use it for the rest of your life of learning engineering and science. So you can use your scientific calculator. You just press shift, then turn, and then 40 of -1. -1. So the answer is -45 degree. That's the answer of our end. This is the angle. So, however, that sometimes you can change it. Can be negative. So the angle is -45 in the second quadrant. But also, if you add this 108, this angle can be 175 positive in the positive. In the anti-clockwise, this is clockwise, this is anti-clockwise, and also it can be equivalent to 315 in anti-clockwise. But simply, just if you find that I'm confusing you, and just conclude that direction of what? Of a given vector which is -2i plus 2j is what? Is -45 degrees. We don't have minutes, we don't have what? We don't have seconds. So then you have to pause the video and do this quiz, just to find this angle quickly within a fraction, within certain seconds you are done with this quiz. Okay? And then wait for the operations of vectors. So now, ladies and gentlemen, allow me now to take you into the next concept of this lecture 4, that's operations of vectors. Say operations of vectors. Well, so the concept of operations of vectors is not a new concept. You encountered it along your journey since you were in nursery school. You have been doing basic operations in mathematics. You have been adding numbers. Possibly, I'm not sure if you have done subtractions, but later on, when you went for the primary education, you've been learning about your basic operations. You've been learning when you have gone to the secondary education, ordinary secondary education, you've been learning about basic operations for the numbers, for the different just in simultaneous equations in different aspects of mathematics. And during your advanced ordinary diploma, you met with operations or operators, basic operators. And the good thing that in computer programming language right now, for example, C or C++ language, we have something we call the Booleans operators, and also we have just logical operators, and then we have logical operators, and also we have computer programming operators. So addition, subtraction. So you see, you have those very important operators. So these concepts of operators, we don't only learn in mathematics, but we apply in our daily life. For example, in writing the programs, because in programs, we have the basic operations, we are adding just one sentence or one aspect, we are adding with another aspect. So one operations plus another operations. We are doing subtractions, we are doing divisions, we are doing multiplications in case of the scientific calculator, the way that they do computations. So we are applying operators in our daily life. And because you are in online undergraduate Polytechnic Institute of Tanzania, in square bracket Olenjolaim, stay tuned. Then that we are going to grasp and we are going to learn different aspects of operations of vectors. And I want to tell you that near future, I'm going to break, which means I'm going to teach you in a very simple language, computer programming languages. Because for the computer programming languages, you need a computer. And to be more practical sessions, and actually that they know that many students will be interested in. It doesn't need too much of maybe of experience. I will be starting from the fundamental concept. So we say that operations of vectors, according to these modules, that we can begin with negative of a vector. Okay, so negative of a vector. So before I teach you about addition, just I'll teach you negative of what? Of a vector. So negative of a vector. So this is what we are going to cover. So the vector negative r is a vector of the same length but opposite directions to a. So you say that the vector a, okay, you say that is a vector of the same length, but same length to vector A, but in opposite directions. I've taught you this in previous session, in opposite direction, right? So simply in mathematics that we say, if you have vector A which has 3 components, A, B, C, and then we are looking negative A, then we are going to negate every element or every vector component. So you can have maybe a vector like this way, okay? That's the way that we can write. So it means that in negative of vector A, it will be negative of element A, negative of element B, negative of element C. So that's the concept that we are going. So in case if you're writing a vector in this form, that vector AB, this is the initial point, this is the final point. So it's negative. We are going to write that in negations of vector AB. Okay, so that's the very important point. So that's what we have to. Okay, we have discussed this one. So negative of a vector we discussed in detail in lecture 3, which is titled as Terminologies of Vectors. Okay, so I believe that you're enjoying the beauty of higher engineering and scientific mathematics. So stay tuned, stay enjoying it, step to step. I believe that God's going to write something in your mind that you'll never forget it for the rest of your life. So then we say that vectors, 2 or more vectors can be added together, or subtracted or multiplied by a scalar quantity. So this is the key point that you have to know. So the basic operations, for that reasons that we say that the basic operations of vectors are, the first one, we're going to discuss about addition. We're going to discuss about subtraction. Then another last operation that we are going to discuss here is scalar multiplication. Scalar multiplications. We'll do vector multiplications later on. So, okay, scalar multiplication. So scalar multiplication. This is just a review of what you have covered during your advanced mathematics or during your advanced education or your ordinary diploma education. But we are just doing quick review of what you know, and later on we are going to teach you new concepts that you have never heard about them. Okay, so if that the case again is that this is the point that we say that we say again that 2 or more vectors. So let us start with additions, okay? Yes, additions and subtractions, so additions of vectors. Addition, so let me teach about addition of 2 vectors. Additions of 2 vectors. So we say that in 2 or more vectors can be added together by either algebraically or geometrically. algebraically or geometrically? So two or more vectors can be added, can be added together algebraically or geometrically. So algebraically, it means that we can add them algebraically, or we can add two or more vectors of one-dimensional or two-dimensional geometrically. So let me begin to teach you about additions of two vectors. Addition of two vectors. Additions of two vectors are algebraical. Algebraical. Additions of two vectors. Additions of two vectors algebraical. Okay. So then we can add two vectors algebraically and see great things that are going to happen. So I say the two or more vectors can be added together algebraically by adding the corresponding components of vectors. That's the sentence that I want to make. Okay, so I believe that you're enjoying the beauty of higher engineering and scientific mathematics for undergraduate students. Good news. So let me speak now mathematically by using letters, because you know that it makes sense for you. So we say that suppose you are given two vectors. You are given vector A, and this vector A, it has the following component: A1, A2, A3. So these are the three components. And then you'll be given vector B. So vector B, also its components are B1, B2, B3. So then, if you want to add vector A and vector B, then we say that we have to add the corresponding components. This is the x-axis component, y-axis component, z-axis component. So it means that if for this case, we are going to have that if you want to express in terms of the point A1 plus B1, then comma, then we are going to take A2 plus B2, then comma, we have what A3 plus B3, and then we close the bracket like this. Okay, so that is additions of the two vectors. Again, we say that, for example, if we are given vector AB, this vector AB, it has AI plus BJ plus CK. But this is A, okay? And then we have against another vector, which is vector BC, right? And then we find that here we have possibility AB, we have AI plus BJ plus CK. So then now, if you're looking vector A plus vector BC, then what happens? So here you have A plus A. So we add the corresponding component. The I components with another I component. The J components we add with another J component. The K components we add with another K component. So A plus this one I plus again B plus capital B J. Okay? Then plus what? Plus C plus capital C K. So at the form. So that's how we add two vectors algebraically. And I'll do a simple example. This stuff are still simple. Okay? This stuff are still simple. This is the review of what you've covered during your ordinary education and during your advanced education. But possibly forgot them, so that's why we are reminding you. And even also your curriculums demand us as teachers to teach you quickly about that concept. So that is additions of the two vectors algebraically. Okay? Additions of two vectors algebraically. Let me teach you, let me check. Of course, I'll teach you also about laws. Okay, additions of the two vectors algebraically. Yeah, so let me teach you about subtraction. And then we'll see what will be next. Okay, so let us continue. So then subtraction. Say subtraction. Subtraction of two or more than two vectors. Subtractions of two or more than two vectors. Subtractions of two vectors is just a special case of addition. Subtraction of two vectors is just a special case of what? Special case of addition. That's why we have laws of adding two vectors. So it's a special case of what? Of addition. Right? Why it is a special case of addition? These are the reasons. Suppose that I have been asked to find these operations, vector v minus vector u. So v minus vector u, then we say that in mathematics we define that this is vector u plus negative of vector v plus negative of vector u. So v minus u is equal to v plus negative u. So that's the formula and that's the principle. Okay? So that's the principle that you are going to do. So for instance, v is equal to, let's say v1 comma v2, right? And then she said that u is equal to u1 comma u2. So if you have been asked to find v minus u, this we say that it is v1 minus v2 comma u1, so comma v2 minus u2. So that's the formula. Okay. The best properties of, okay, so let me do an example. So example 6, simple example. Again, before I just give you this example, we have something very important, especially in matrices, and especially because in the next semester, even still in this course, that you'll have something about vectors. That's why that the topic is called vector algebra. So we say that we have something, we call it in maths column vector. So column vector, this is a vector which has been expressed in this form. And then we have again, so example is if vector v is a column vector, it has elements a, b, c, at the column vector. Then so again we have another vector that we call it row vector. So row vector, this comprises only one row but more than one column. Just like this one, contains only one column but more than one rows. So example, if you have vector u and then it has been written in form of row vector, then it will be a, comma, b, comma, c. In case of column vector, we don't have a comma in between the vector components. So then afterward now, let me just present to you example 6. And this example 6 will be given the 2-column vector. Oh, excuse me. So given vector A is equal to 2, 4, 2, 4, negative 5. And the vector B, this is 2, 8, 2. Okay? Then the question asks us to find A plus B. Then B, this we find A minus B. No, B minus A. Yes, B minus A. Let us replace vector B minus vector A. So you have Roman A and Roman B. So I will do one and the other ones will be the homework for you. Okay? So you have to stay tuned. So what the name of this vector? It is called what? Column vector. Column vector, column vector, column vector, column vector. Do you love column vector? Tell me in the comment section, please. Okay? So we say that, okay, solution. Every part is very simple for undergraduate students. Roman A, we are looking for A plus B. A plus B, this means that we have column vector, which is 2, 4, negative 5. Okay? Then plus what? 2, 8, 2. So you say that vector A plus vector B, this is equal to what? This is equal to 2 plus 2 makes 4. 4 plus 8 makes 12. Negative 5 plus 2 makes what? Negative 7. So therefore, if you take vector A plus vector B, in terms of column vector, we get 4, we get 12, then we get negative 7. So then this Roman B, this is quiz. It's not even a homework. It's just a simple question. It's a quiz. Okay. So before I teach you about, I've talked you about the additions of the two vectors, subtraction of the two vectors. Before I teach you about basic properties of operations of vectors, let me teach you another basic operations of vectors, which we call the scalar multiplications. After I teach you scalar multiplications, the next step, I will teach you about basic properties of vector, of operations of vector, and then later on I will teach you how we do the basic operations of the two vector geometrically. Stay tuned. Don't quit, please. Okay? So let me teach you about so we say that the next step, we say that what? You study, okay. So scalar multiplication. Scalar multiplication of what? Of vector. Scalar multiplications of vectors. Scalar multiplications of vectors. Scalar multiplications of vectors. Scalar multiplications of vectors. And hence, just let me refer your reference material. Scalar multiplications of vectors. Say with me, scalar multiplications of vectors. Scalar multiplications of vectors, simply say that is a basic operation, is the basic operations of vector, of vectors, whereby the scalar quantity, say scalar quantity, which does not have direction at the means of scalar quantity. The scalar quantity, it depends. Some of the books use K and T. Yes, K and T, I think that is. Some of the books use S. Yes, S. So K, T, and S, these are the common symbols. Whereby the scalar quantity, such as K or T or S, is multiplied to each component of vector. Are the meanings of scalar multiplication of vector. That's all. That's all. So it can be given a vector and then it can be asked to do the scalar multiplications of these two quantities, and this process will be very interesting, very new. Okay, so it means that generally we say that a scalar, for example, that generally suppose that we are given vector A. This is equal to A1, okay, plus A2 plus A2 plus A3, okay. Okay, and then we say that okay, and what? And the scalar quantity is T. Then, for example, if you'll be asked to find that T times N, this is equal to what? After T, then I multiply with vector A, which is A1I plus what? A2J plus what? A3K. Okay? So it means if I find the scalar multiplication, then I'm going to have T A1 times A1I, then plus what? T times A2J, then T times A3K. Okay. So that's this the scalar multiplications of T and what? Scalar multiplications of T and A. A scalar quantity can be a letter or a number. So remember that. Not. So that a scalar quantity may be a number or arbitrary constant. Arbitrary constant means arbitrary letter, which is STK. When you say that it might be a number, for example, that will be given maybe vector A is equal to A, B, C, for instance, then we've been asked to find 12A. So 12 is a scalar. So simply this one we get by taking 12 and multiply to all the three elements of vector A. So this is the scalar quantity. If a scalar quantity is a letter, then this is the symbol, or this is the way that we used to do notation. Okay. I believe that you're enjoying the beauty of this lecture 4, which is very simple. It's one of the simplest lectures. Okay. Then another piece of information that we need to know we can have an example. So example 5, 6, this is example 7. Okay, example 7. Given vector A, which is what? This we call what? Raw vector. And another vector B also is in form of row. Okay. Then the question asks you that now you as a student do these simple questions. 3a plus 8b, and then we have another case. We have 4a minus 2b. So okay, so it's simple. Let me leave this one as quiz for you. Let me do this of subtraction. Solution. It's very simple question, more than you think. Solution. So you're looking for 4a for the response of vector 4a, which is scalar multiple. This is scalar multiplications of vector a with the scalar quantity 4, which is equal to 4. Then minus what? 2b. So to do these operations, we have 4. We have a as a scalar quantity, and this is scalar quantity is 4, 6, then negative 2. Okay? And then we say that minus 2, then we substitute the elements of vector b. So negative 4, negative 7, negative 1. Okay? So then we say that 4a times 2b, this is equal to what? 4 times 4, it is 16. Okay, it is 16, comma, what? 4 times 6, it is 24. 4 times negative 2, it is negative 8. Then minus. Okay, minus what? 2 times negative 8, it is negative 4, it is negative 8. Negative 2 times negative 7, it is 14. Negative 2 times negative 1, it is 2. Right? So we have to proceed. 4a minus 2b, this is equal to what? 16 minus negative 8. This will make what? 24. And then we have again 24 minus 14. The answer is what? 10. Comma, negative 8 minus 2. The answer is what? Negative 10. So this is the response. Okay? So that's the final response. Okay. So if that's the case, we say that this is interesting. This is good news. Okay? This is good news. Then that's all about scalar multiplications. I believe that now you are very competent in doing scalar multiplications of vector quantities. So ladies and gentlemen, right now, allow me to teach you about basic properties of 14. So modulus is matrices and basic calculus. Basic properties. So allow me to teach you about basic properties. Very important properties. We are going to use them in the near future. Properties of 14 of operations of vectors. Operations of vectors. When we say operations of vectors, it means addition, subtraction, and the operations of 14, operations of vectors, and scalar multiplication. I will teach you. The next sessions will be about dot product. Get prepared in a different way, in undergraduate level, because we can learn the concepts of dot products by using letters in a very different way. So get prepared for the lecture 5. So basic properties of operations of vectors. Okay. So these basic properties we still remember about basic properties of set and basic properties of what? Of logic. We call them properties of logic and properties of what? Yes, properties. We used to learn those properties in set. Associative property, commutative property, idempotent property, and then we have against what we call it negation property, or we call it just completely, we call it just negation, De Morgan's property in place of the logic. So even here, we are going to learn those properties, which are very important in mathematics. So stay tuned. So he said that the following theorem state basic properties of following theorem state the basic property, state the basic property, the basic properties, state the basic properties, take the basic properties of vector addition, of vector addition, of vector addition, of vector addition, okay, of vector addition, of vector additions. And the theorem, this is the theorem, here the theorem, here the theorem, here the theorem, here the theorem. Let what? Let U, V, W be vectors, and let you can bold this U, V, and W, and let K or L be scalars. K and L's, or K, L to be scalars. Okay? Then the following relationship hold, or the following theorems are correct. So this presenting three vectors. So let U, V, and W be vectors, and let K, L be scalars, scalar quantities. Then we can establish the following theorem and apply in engineering, in science, when we are dealing with real life problems. Okay, so we said that now the following. So we said that the following properties holds. So the first property, we call it associative property. You remember about associative theorem, associative theorem, or we call it associative law. How can we show associative law according to what we've taught you in set, right? The first topic in Form 5. So it's the associative law. We have now, we don't have the two sets, we just have we have just the vectors. So it's a U plus open bracket V, then plus what? W. This one also is equal to U plus V, then plus W. Then plus W. Okay, so this is the first vector, first associative law. Again, we have two scalar quantity, which is K. When you have K, open bracket L times V, times vector V, times vector V. So you can bold this U just to separate it from the scalar quantity. Okay, so here we have W. Okay, so this is K L, and here we have K L times 40 vector V. That's associative law. Sorry? Now say that the bracket now will be excluding we have a bracket, so we have a multiplication first between the two scalar quantity, and then we multiply with vector v. So this is vector v, this is vector u, this is w, this is w. Okay. So that's associative law. Then we go for the next law. Okay? Associative law, which holds, we have commutative law. Commutative law. Commutative, say commutative. Commutative law. We need these laws in vector. Commutative law. So how does commutative law state? We have vector u, then we plus with vector v, and this is equal to vector v plus vector u. That's the commutative. Or we can take vector v plus vector w, and this is equal to, if we start writing vector w plus vector v. That's all about commutative law. Then the third law that we need in vector, we call it distributive law. Say distributive law. Say it again. Say distributive law. Distributive law. Say distributive law. So in distributive law, it's very interesting, especially even in case of the set. So we have two distributive laws. Okay? We have two distributive laws. So if you remember that maybe you have vector A, you have vector B, you have vector C. Do you remember? The distributive law for vector, we say that we have vector A, then we say that intersection what? Vector B union vector C. Do you remember that? So then we open. It means that this is equal to vector A intersection. What? Set A intersection set B, and then we say that union what? Union set A intersection set C. Okay? So that is in case of vector. So let me not confusing you. Okay? So then here we say that we have, for instance, a scalar quantity k, and then we multiply with the summation of two vectors, which is vector u and k. So if you do this multiplication, we get the scalar quantity k times u plus what? The scalar quantity k times v. That's the first distributive law. The second distributive law right now is we have to take k plus l. K plus l times what? Times vector u. Times vector u. So times vector v. So this one, say k times l or k times v, so you're going to have k times v plus what? L times v. So these are distributive laws of vector, where k and l are scalar quantity. So you see, so it means we take k times vector v, we get kv plus l times vector v. So this is scalar multiplication, scalar multiplication, scalar multiplication, scalar multiplication. This is also scalar multiplications, but with additions of 14 of two vectors. All right. So do you think there are other laws? Yeah, there are other laws that I will leave homework for you to name. How do we name them, or how we name them in set, because set also is a topic of algebra. It's one of the topic of algebra. Okay? Again, other laws, we say that we can have scalar quantity k, and then say we have L times u. Okay? So this also is equal to what? You can take L out, and then we take scalar k times what? Times o. Okay? We have other laws. Okay? We'll teach you about other laws. Other laws. And as a law, we have vector u plus negations. This we call it negation law. Okay, we used to call it instead negation law. So vector u plus negation, so negative of vector u is equal to 0. And if we take vector u, we add with 0, we get vector u. And again, if we take this u plus 0 is equal to 0 plus u, and this also is equal to 0 plus u. Okay? Then we say that we have, if you have 1 multiplied by vector w, then the answer is equal to w. Okay? So you can also take just let two vectors, two scalar quantities, 3 vectors, okay, means 3 vectors, and then those 3 scalar quantities, and then you prove those laws if they are valid or they are not valid. So that's how you enjoy the beauty of engineering mathematics. So then, the next step right now, which should be the last part of this session, is to teach you about operations or basic operations of vectors geometrically. Okay, so now let me teach you the last part for this lecture 4, which is titled as addition, or let us additions, okay? We can say that addition is the common operation, addition of 2 vectors. Additions or addition of 2 vectors geometrically. Geometrically. Addition of 2 vectors geometrically. Additions of 2 vectors geometrically. Addition of 2 vectors geometrically. So you say that 2 or more vectors can be added together geometrically to obtain a resultant vector. Okay? So let us speak now as mathematicians, and let us speak geometrically more than algebraically. So I'm going to sketch 2 vectors. Okay? So consider figure 4.21 below. And I'm going to sketch the XY plane, so the 2 vectors in XY plane. This is y-axis, and also here we do have the x-axis. And this is 0, 0. So this is x-axis, and this is y-axis. So suppose that we have 2 vectors, okay? We have 2 displacement vectors, and these displacement vectors, we have 2 displacement vectors which have the same initial point, such as this displacement vector. This vector is in this direction. Suppose that this is vector A. Again, at the end of vector A, Also, we have another vector. So this is certain point. This is another vector called the vector B. So this is the initial point of the vector, and this is the final point, right? The beginning of the vector, the end of the vector. Suppose that this is point A, this is point B, this is point C. So now we want to add these two vectors geometrically because this vector contains two components, X components and the Y component. So how are we going to add? Because this we call the triangle law. Okay? So this we call it the triangle law. And you know where did you learn for it, where you learn it for the first time is during your form series, during your physics, when you have been learning your physics form series, the first chapter, which is called the applications of what? Applications of vectors. So this we call the triangle law of what? Of vectors. So how can we add these two vectors geometrically? Well, so it means that the aim of if this is the trip from point A to point B, then from point B to point C, okay, that's fine. We can have also a shortcut, right? Because our aim is to leave the starting point A to the final point of the destination point C. Okay? So destination point 30, destination point C. Destination point C. Okay. Destination point C. Okay? Destination point C. So we are starting from point A to point C, just like this one. Okay? So from point A to point C. From point A to point B. Then from point B to point C. Okay. So then this is 20, this is, let's say that it's a vector C. So the journey is from A to B, B to A, B to C. A shortcut can move from A to C. So this we call the resultant vector. So this we call the resultant vector. Resultant vector. So from that aspect, or from that, so this is figure 4.1. So from this triangle law, we develop a very important formula, and it's very powerful. We are going to use it in many cases. I have to say resultant vector C for this case will be equal to vector A plus vector B. When you've been learning the concepts of ratio theorem, then you use this concept often when you are deriving about the midpoint of the vector, when you've been deriving the formula, the general formula of determining the internal divisions of vector, and also the general formula of determining the external divisions of vector. During your ordered diploma, we taught you. During your advanced educations, also we taught you in the topic that's called the vector. That's the second topic of Form 6 Advanced Mathematics. So resultant vector C is equal to vector A plus vector B. So this is the first formula. Then we can develop the second formula that vector A is equal to resultant vector C minus vector B. Also, we can develop the third formula. So we have three formulas there. Resultant vector C minus vector A. So this is the third formula. So you see how mathematics is beautiful. That's all about triangle law. That's what you have to know as engineer, right? Things are very simple. These are still simple concepts. We'll get into advanced concepts, and then that your head will get pain. Okay, and you have to understand that this triangle law, it doesn't mean that the resultant vector always will be, maybe it will have a long line compared to other vectors. I can change the direction. For example, if I change the directions, okay, for instance, if I change directions of this, it means that what do I mean? I can have also a case that initial of the vector, this is initial point, let's say point A, then I go to point B, and then I can also leave point B to point C, where is my destination. And then, but also I can leave point A to point C. So suppose that this is what? So suppose that this, just as the way that we've labeled here, this is vector B, and this is vector C, okay, and this is vector what? Vector A. Suppose like that ones. So how do we write the resultant vector? Remember, this is the initial point to B, then we leave B to C. So this is one route, if for example it's a journey or it's a route or a trajectory of aircraft, maybe from Dar es Salaam to Zanzibar, or maybe from Dar es Salaam to Dodoma, or from Dodoma to Mwanza. So that's one route. But another route, the flight can fly from Dodoma to Kilimanjaro and then leave from Kilimanjaro, which is Kilimanjaro International Airport, towards where? Mwanza. So that's the good example of triangle law. So for this case, you just check the initial, means that our resultant vector today is vector B. So you say that vector B is equal to what? Is equal to vector A plus what? Vector C. Interesting. No need for you to claim that always a resultant vector will be labeled as vector C. That's not true. You have to think geometrically as a great mathematician of our time. Again, that is about triangle law. Again, we need another law in case of adding two vectors geometrically. And this law, we call it parallelogram law. Parallelogram law. That's another law right now. Okay? We can add two vectors. Okay, we can add two vectors geometrically by using parallelogram law. Parallelogram law. Okay, parallelogram law. How do we add? So look, so it means that the resultant vector will be a diagonal. So it means that we say that two vectors, if two vectors share the common point, the common initial point, and the resultant will be diagonal of the parallelogram. So we say that if two vectors are added geometrically and they share, these two vectors share common what? Common initial point. Common initial point. Okay? So then we say that then the resultant vector is a diagonal of a vector. It's diagonal of a vector. So it's diagonal of a parallelogram, not a vector. Parallelogram. So again, let us consider this figure. This will be now figure 4.2. I want to show you how we add two vectors by using parallelogram law. This is equal to parallelogram law. Parallelogram law. Okay? So then we have to make sure that parallelogram law, say parallelogram law. So let me show you geometrically. This is x-axis. Okay? That's already. Let me show you parallelogram law. So parallelogram law, we need two vectors which have the same initial, but now they are not establishing the triangle like in triangle law. Okay, so now they are establishing the triangle as a triangle. So you are going to have two vectors which are two positional vectors. Suppose that we have two positional vectors, and I'll try myself my level best to sketch these two positional vectors. One positional vector is from here. The other positional vector is from origin towards somewhere. So this is the positional vector A, and this is positional vector B. And then you know what happens? This positional vector here, it has three points. It has, let's say that x1 just 2 points. This is x1, comma y1. So x1 is formed here. Okay? Then another point, so we say that this is x2, comma y2. So this is also another vector, which is vector B. Okay? So then, what happened? So you say the resultant vector right now will be a diagonal of parallelogram. So let us establish, let us draw another parallel vector to vector A. So we can draw it in this style. We can use dotted line. So this is the parallel vector to vector what? To vector A. I'll try my level best to sketch. And then you can have another parallel vector to vector B. Because you have instrument or the drawings instrument you can draw. So suppose that this is point O, and also this is point A, this is point B, this is point C. So this now is a parallelogram. So you say that O, A, B, C is the parallelogram. So that's the parallelogram. And then now we are going to have a diagonal. We are going to have a diagonal. Going to have a diagonal. Okay? Going to have a diagonal. So to have this diagonal, we say that here we are going to have a resultant vector. So diagonal, so it means that you say O, B is a diagonal. Not diagonal matrix, is a diagonal vector. Diagonal vector. So this diagonal vector now should be a resultant of vector A plus vector B. So because we have added two vectors geometrically in such a way that the two vectors, when you sketch them, they have established what? They've established a figure called the parallelogram, which we've been discussing since then. So this is the way that we can add two vectors geometrically. Okay? So it means, for instance, if here we want to find the resultant vector, which we say that is a diagonal. So resultant vector for this case, this is equal to vector A plus vector B, which is equal to what? Diagonal. What are the components of vector A? It is x1, y1 plus what? x2, y2. If you add this component, this is x1 plus x2, what? y1 plus y2. That's the concept that you have to know. Okay, so if that's the case, I think that it is, I hear from my heart, I hear in my heart that the Lord saying, OLENJOLAI today it is enough. The rest of the contents, we'll cover them in the lecture 5. So let me end this session with homework 4. And this will be example, because we had example 5, 6, 7, example 8. And this example 8 is, we say that with 8 of diagram, diagram, state how can we add more than 2 vectors by using polygon law? That's the question. We have 3 laws in vectors: triangle law, parallelogram law, and polygon law. So polygon law is the homework. So it means that we're using with aid of diagrams like how I taught you triangle law and how I taught you parallelogram law, then explains or just state how we can add more than, because remember that this is, you have to remember, triangle law and parallelogram law are limited to add only 2 vectors. So what if we want to add more than 1 vector geometrically? Then there we need polygons law. Polygons law, not pentagon law, not hexagon law, polygons law. So polygons law is the only law which can help us, which can help us to add more than 2 vector geometrically. So state the polygons law with the aid of diagrams, and then state how do we add 2 vectors or 3 vectors or 4 vectors. You have to make sure this is the condition, that you have to make sure that in your diagrams you include more than 2 vectors, because that's the beauty and uniqueness of the polygons law. Okay? Well, once you finish that exercise and you do that homework, make sure that you do this homework and you submit your homework in the comment sections before we meet together in the next lecture, which will be in lecture 5, where now I'm going to start teaching you, or I'm going to teach you about the dot product of the vector. So this is the end of lecture 4. I'm a little bit happy because I've poured out what God has taught me. And I thank God who have created me in his own image and likeness, because I'm come from him and I'm here to do a special assignment. And once I accomplish it, I have to go back to him and live with him forever and ever. How about you? That's the question that you have to ask yourself, because you have to know the way. The Lord Jesus is the way. Okay, so then I thank God, and I thank God who have given us the opportunity to join me. I really appreciate, and I would like to say thank you, the word of thank you for joining me. I would just like to remind you some few things which are very important for you to be stayed connected. Remember that you are in online undergraduate polytechnic institute of online undergraduate polytechnic institute of Tanzania square bracket Olenjolaim. We will ask you that in case you feel from your heart you want to offer our God, who is the most high God, you are free willing thanksgivings, because we don't need actual that we call it just misada. We don't need that once. Okay, so because once you offer it by faith, and then God is going to bless you abundantly more than what you have offered. So he can send you a free willing thanksgivings through this telephone number 0759745331, so that you will be supporting the running cost for more videos of matrices and basic calculus to be in air for the present and future generation. And believe me that God will never forget your offering. Again, we ask you, or we remind you to subscribe in our channel, because we add always new videos in our platform, so that the YouTube community will give you notifications. So you have to understand, and also you have to get updated as soon as we release a new video. Again, we ask you that to share these contents to every student who is doing engineering course or science course in Tanzania or in African continent. And then ask them to go through these contents for the rest of the year life, to keep these lectures, to watch them, and then read the descriptions below, so that you can know, because you have also online library, and you can know even the links that we can send to your young brothers or young sisters who are still in O-level education, who are still in advanced educations. So means that you just get prepared that now the digital technology or the digital knowledge is in your house, and you have been overwhelmed with all the important information. So I thank you very much. I really appreciate and dedicate this session to all my classmates who did their undergraduate studies at University of Dar es Salaam, who we studied together during our advanced education in 2008, so 2010, and most of them, I think that more than 50%, they were students of College of Engineering at University of Dar es Salaam. So may God bless them. I really appreciate their support. They taught me so many concepts, and even I'm still using right now. So I would like to say thank you, and I invite you in the next lecture. I'm praying always for you. I ask you also to pray for me. Make sure that you remember the visions in online undergraduate Polytechnic Institute of Tanzania, and square bracket Olenjolaim. We are here to help you to extract knowledge from the formal and informal education, to combine with the knowledge from the Word of God in order to solve real life problems. So think about that. Think about where you're going to apply this information that they taught you in lecture 4. So may God bless you and keep you safe until we meet in the next lecture.